Good evening, everyone. My name is Varun Kumar BP, and I am currently pursuing my engineering degree. I am also working as a data center engineering at 3QI2613 LLP, where I am gaining practical exposure networking concepts and real-time system environments. Today, I am going to explain my project based on network design, routing, and enterprise network using Cisco Packet Tracer. These projects focus on network reliability, scalability, and security, where which we are important in a real world enterprise network. Next, I am going to show our the project name is six router network with secure segmentation. Enterprise network architecture features featuring six routers, 18 switches, and VLAN based security isolation across multiple sites. Uh, the project planning overview topology design six router backbone with 18 switch access layer mapped for optimal connectivity. Next VLAN configuration VLAN 100, 200, 300 defined with 80Q 802.1Q tracking all across switches. Our routing setup RIP v version 2 initialized for dynamic path discovery between all the routers. And in this VLAN configuration, we introduce VLAN 1 for DHCP server. This is the next. This is the network design and architecture of the network. Router to PC connections. Each of the six routers establish local connectivity via GigaNet Ethernet interfaces. These connections has the primary access points for all local PC segments, ensuring high-speed data transfer and efficient organization for client devices with each department. Network segments and VLAN overview. The traffic segmented into three distinct VLAN to ensure department isolation and efficient resource management across the network. VLAN 100 management, VLAN 200 engineering, VLAN 300 for general. The IP address for these VLANs 192.168.100.0, 200.0, 300.0. The gateway is 100.1, 200.1, 300.1. This is the network design and architecture of this project. The next one is the network connectivity and IP addressing and router interconnection details. The six router backbone utilizes a star mesh hybrid topology where routers are interconnected via dedicated serial Ethernet links to ensure robust and redundant communication paths across the network. Each network has one server. Each network contains 60 PCs. Inter-router IP addressing. The transit networks between routers are defined by following IP addressing scheme. R1 and R2 link between 7.0 network. These are the six routers connections between them. We use it as 7.0, 8.0, 9.0, 10.0, and 11.0 and 12.0 for these inter-router IP addressing. IP address distribution is like 1.0 for LAN network, 1.0, 2.0, 3.0, 4.0, 5.0, and 6.0. These are all the IP addressing and network connectivity. The main character of this project is a DHCP configuration. It is used to network management by automatically assigning IP addressing and the network configuration parameters to client devices, reducing manual configuration overhead. DHCP server details. Details. So the centralized DHCP server handles address distribution across the topology. Server IP is 192.168.1.2. Subnet mask 255.255.255.0. Configuration global pool management with static reservation enabled for critical infrastructure nodes. IP pool configuration. Each network segment maintains a dedicated scope for its local devices. Pool range is by 192.168.1.10 to 192.168.1.254. The excluded range is by 192.168.1.10 to 192.168.199, reserved for gateway and server addresses. DSCP relay configuration. Since DSCP server resides on network 2, routers are configured to act as a DSCP relays to forward requests across the subnets. Implementation using IP helper address 192.168.1.2. Placement applied to gateway interference, sub-interference for each local VLAN network segment. Lease management, client management, first come, first served basis with defined pool range. The implementation execution, first we physical linkage and VLAN trunking and sub interference. 6 routers connected via serial cables, each linked to 3 switch stack. Switches configured with 100 VLANs, 100, 200, 300. Router ports set trunk mode. Sub interference, gigabit 0.1, gigabit 0/2 and gigabit 0/3, created with 802.1q encapsulation. This is the the next process, the testing and validation. First we test connectivity tests, ping and trace route, validate reachability across 6 router mesh and to central server. RIP verification, show IP route RIP confirmed protocol convergence with complete routing tables. Troubleshooting methodology, layer 1 to physical issues, verify line protocol status and trunk mode using shows interface, trunk and shows interface status commands. Layer 3, routing problems, check DHCP relay configuration and RIP adjustments with debug IP RIP and show IP protocols. Project results and performance. 6 routers, 18 switches, and 100% DSCP success. IP leases on first attempt. 18 switches, VLAN created, 100, 200, 300 configured. 6 routers, so full IP convergence across backbone. Routing efficiency, RIP version 2 populated all routing tables, convergence time acceptable for enterprise parameters. VLAN integrity. Router on stick handled multi-VLAN traffic through a single interference with a stable CPU utilization. For security implementation, we extended the ACL. ACL is nothing but access controlled list 110 blocks inter VLAN communication while permitting DSCP and management traffic. Implicit DENI policy. Users in one segment cannot access resources in another unless specifically authorized. Hit count monitoring shows access list 110 verified unauthorized packets identified and dropped at gateway. Key achievements: centralized IP management, DSCP relay mechanisms successfully served 6 different branches from single server, automated routing, RIP version 2, eliminated manual route entry across multi-site architecture. Project completion summary: operational network, 6 router and 18 switches fully configured with complete documentation and full connectivity, RIP convergence verified across entire backbone infrastructure. This is the network design of our project. See here, in ring topology, it's look like ring topology. There are six routers. Each router have a three switches connected together, and for every network, one DSCP server is connected. And each switches have 20 PCs. In the 20 PCs, we divided 1 to 10 for VLAN 100 and 11 to 15 for VLAN 200, 16 to 20 for VLAN 300, and we assign VLAN 1 for DSCP server. And we using ACL method for security purpose. VLAN 1 should communicate with all VLANs, but VLAN 1, 2, 3 should not be communicate each other. These three are communicate with VLAN 1. This is the security I implemented in the project. Thank you. Now I am showing the demo of our project. The the main conclusion of this project, the project demonstrates scalable, efficient ISP network design using dynamic routing. See, this is the our network design. Network design. We for this network design, we I used Cisco packet tracer. See, automatically DSCP server is assigned already IP addresses. I explain one network. It's similar to all other networks. Uh, See here, all switches are connected with each other. DSCP server is assigning IP addresses automatically. Now I ping. This one is 20th PC. This one is first one PC. I ping now. Ping 192.168.1.108. I did not get reply because VLAN for the first PC is in another VLAN. The 20th PC is another VLAN. See, it's coming destination host unreachable. The destination host is unreachable. This is done using ACL access control list. Now I ping 19th PC. These are in same network. 19th PC. The IP address is 1.224. Now I see. I get reply from 19th PC because 19th PC and 20th PC are in same VLAN network, so they are communicate with each other. The first one is another VLAN, so that's why it does not communicate with another network. I communicate with another network. I will say one. Wait a minute. This one is the 20th PC. 20th PC for this one 2.206. Now I ping 2.206. Yeah. I get reply from the another network because we 20th PC and the network to 20th PC in the same VLAN, so it communicate with each other. This is the main aim of our project. I show our This is the steps we taken for this project. First, we done a project initiation and proposal. The project plan. Next step is project planning. The project execution and implementation. Next, monitoring and controlling. The next project closing. These are the steps I taken for this project. This is all about our six routers network project. This is like an enterprise network in the real world real time environment. Thank you.